Okay, so today's lesson, you're going to learn how to graph logarithm functions. But before we do that part, let's go ahead and find the inverse of the following functions. Just because you do need to know that if you have an exponential function such as f of x equals beta dx, then the inverse of an exponential function is going to be the log function. So that's the inverse here. So same thing with the other way around. If you have a log function and you find the inverse, that will be an exponential function. So these right here, numbers 1 through 4, let's go ahead and just find the inverse. The way you find an inverse is you would switch the x and the y values, or the variables, I guess. So we're going to put x equals 5 raised to the 2y plus 4. Now to solve for y, I'm going to do a minus 4 first. So x minus 4 equals 5 raised to the 2y. And now, in order to solve this equation, this is an exponential equation because you have a base of 5 raised to the 2y. In order to solve that, you're going to have to write this in logarithm form. So that's what we learned in our last lesson. So this is called exponential form. I'm going to change it to log form by writing log base 5 of x minus 4 equals the exponent 2y. So that's what we learned in our last lesson, how to write exponential form to log form. So now I have log base 5 of x minus 4 is equal to 2y. And now I can just solve for y by dividing by 2. Or you can just do 1/2 times the log base 5 of x minus 4 equals to the inverse. I did 1/2 times the log, but you could have just done log base 5 of x minus 4 all divided by 2. It's the same thing. But that's how you find an inverse of an exponential function. We can try it again on example 2. We're going to put x equals 3 times 2 to the y plus 1. First divide by 3. Oops. Okay. Divide by 3. So x divided by 3, or you can put 1/3 x. Equals 2 to the y plus 1. Now change this exponential into a log form. So log base 2 of 1/3 x equals y plus 1. And now you can solve for y by doing a minus 1. So log base 2 of 1/3 x minus 1 equals the inverse. So you will be finding inverses on your quiz next week and on your test. Next is examples 3 and 4. It's the same thing, but now you're starting with the log function and you're going to find the inverse of that. So number 3, switch the x and the y variables. So x equals log base 4 of y minus 2. Now that's a log form, so now you need to change it to an exponential form so that you can solve for y. So the exponential form would be 4 raised to the x equals the y minus 2. So I can just add 2. 4 raised to the x plus a 2 equals y, or I'm just going to put f inverse. And we can do it one more time on example 4. X equals natural log of 6y plus a 1. Move the plus 1 over with the minus 1. X minus 1 equals natural log of 6y. I like to put it in parentheses, but it's okay to put just natural log of 6y, but I always like to put in parentheses. This log has a base of e because it's the natural log. So if I change it to exponential, it would be e raised to the x minus 1 equals 6y. And then you can just divide by 6 or multiply by 1/6. 1/6 times e to the x minus 1 equals the inverse. Okay, so you need to know how to find inverse functions next week on the quiz. I think the quiz is Monday during class. Yeah, so Monday or Tuesday for B days. Monday during class over all of the exponential lessons that we've done and then all of the log lessons that we've done, including today. So now, okay, now that we've gone over inverses, now we need to know how to graph a log. So example 5. Let's see. Okay, example 5. A couple things you need to know about the logs. I think I wrote it on the answer key, but the generic form of the log equations is y equals a times whatever log with whatever base you're given of b times x minus c plus d. This is like in parentheses here. Okay, so this is the generic form of the logs. The A is a vertical stretch or shrink. The D is a vertical shift up and down. The lowercase b is a horizontal stretch or shrink. And then the C is a horizontal shift. So let's try to graph something like example 5 that has log base 2 of x. Okay, there's different ways to graph log base 2 of x, but here's what I do. Basically, I graph the inverse, I guess, or I make a table for the inverse, and then I switch the x and y point. So let me show you what I'm talking about. So number 5, if this is my function, then I can find the inverse by doing x equals log base 2 of y, and then I can do 2 to the x power equals y. Okay, so this is the inverse. Inverse. So what I like to do is I like to make a little table of values for the inverse, and then when I graph it, I just have to switch the x and the y values, and then I'll be graphing the real function. So let me make a table for the inverse. Let's put it over here because it doesn't fit there. So again, I'm graphing the inverse, or I'm making a table for the inverse. So if x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 4. That's all we need. 3 dots is enough. So this is the table for the inverse. Again, inverse. So now you can go ahead and like flip the x and the y values so that you can have a table for the actual graph. So then that means my actual function, y equals log base 2 of x. If I wanted to make a table for that, I would just copy the inverse and flip the values around. So instead of 0, 1, it's 1, 0. Instead of 1, 2, it's 2, 1. And instead of 2, 4 is 4, 2. A couple things I forgot to tell you about the logs. Let me just give you the facts, like the key features, domain, range, asymptotes and stuff. So for all of the logs, first of all, I'm thinking, okay, so for the logs, the domain is gonna be from C to infinity, as long as there's no reflections, and we'll try some. The range for the logs is gonna be all real numbers. All real numbers. And then the asymptote for the logs, they have an asymptote. It's gonna be x equals c. So that's some information you do need to know. You need to know that for logs, the domain is restricted and it's going to start at the asymptote and go towards infinity. unless it's been reflected over the y-axis. The range for the logs is going to be all real numbers, so it's the opposite of the exponential graphs. And then the asymptote is no longer going to be like the y equals d. That's for the exponentials. For this one, for logs, your asymptote is going to be x equals c. So now that I've told you that, we can try to graph some of these dots. So let's graph 1, 0, 2, 1, 4, 2, 3, 4, 2. Okay, so here's what it's going to look like. It's going to look like that. And because there was like no c value, like no shift, that means that the asymptote is at x equals 0. So I'm going to write it down, asymptote, x equals 0. The domain, it looks like the x values will be from 0 to infinity, but not including 0. The y values will be all real numbers always for all of the logs. All real numbers. I think I'm supposed to put the little r thing. The x-intercept, you can see on the graph that the x-intercept is 1, 0. And you can also see that there is no y-intercept because that's the asymptote. And finally, just like when we did exponentials, the increasing or decreasing, you just need to look at your graph from left to right. So as x gets larger and larger, the y values are getting bigger and bigger. So that's called increasing. And that's how I graph logs. So let's just practice again. Number 6 has, example 6, you're going to be graphing f of 3 log base 2 of x minus 1 minus 4. So basically, we already have the log base 2 parent here. So we already know the points on log base 2. The points were 1, 0, 2, 1, 4, 2. We know that. And now we can just apply these transformations to the points here to give us example 6. So that's what I'm going to do. So I'm going to make a table for example 6. And the table that I'm going to make is, I'm just going to take the table that I already have for log base 2 of x, so it's right here. And first of all, what kind of transformations? The x minus 1 is actually a shift to the right one, because c is a 1 here. So I'm going to do plus 1, because I moved right 1. The 3 is a vertical stretch, so it's going to affect the y values by 3, so 3y, and then a minus 4. So this is a vertical stretch by 3, down 4. So that's what I'm going to do to the points of log base 2 of x. So I'm going to do x plus 1. 1, 2, 3, 5. And now I'm going to do the y values. So for the y values, I'm going to do 3 times y minus 4. Negative 4. Negative 1. 6. 2. I think that looks right. If not, someone say something. So now basically this is what I'm going to be graphing. And I always like to do to graph that asymptote first. It should always be x equals c. So for this case, it's x equals 1. So let's go graph that. That's the asymptote. So now you can graph the points. 2, negative 4. 3, negative 1. 5, comma 2. 4, 5, 1, 2. So it's going to look like this. It's been vertically stretched. So it's going to look like that. Now, based on your graph, you can find the information here. The x values go from 1 to infinity again. Don't include the 1. The y values is always all real numbers. Oh, I guess I should put negative infinity to infinity. It doesn't matter. The x and y intercepts, we're going to have to actually find them out, although there is no y-intercept because it never crosses the y-axis again. So for the x-intercept, we can't eyeball it because I don't know what it is. It's like 3 point something. So we're just going to actually just figure out the x-intercept by plugging 0 for y and solving the equation. So I'm going to plug in 0 equals 3 log base 2 of x minus 1 minus 4. So you can solve this log equation like I taught you last time. To solve it, let's do a plus 4 and divide by 3 at the same time. So it will be 4/3 equals log base 2 of x minus 1. You want to change the log into an exponential so that you can solve for x. So this would be 2 raised to the 4/3 equals x minus 1, and then if I just add 1, you'll have your x-intercept. So the x-intercept is 2 raised to the 4/3 minus 1. So that's acceptable, 2 raised to the 4/3 minus 1, but if it's multiple choice, you might not see that. You need to recognize 2 raised...
Yeah, isn't it plus 1?
Oh, you are paying attention. Yes. Thank you. Okay, so that's correct. Plus 1. So you can leave it like that, but like I was trying to say, if it's multiple choice, like on my test, I don't think you'll see it like that as 2 raised to the 4/3 plus 1. You'll see it as I changed it to a radical form. So what did I do? So let me change it to a radical form. This would be 2 raised to the 4/3 is the cube root of 2 to the 4th plus 1. So those are equivalent. And then I even simplify this. So on my answer key, you will see that the cube root of 2 to the 4th is 2 cube root of 2 plus 1, comma 0. So if it's free response, they're both acceptable. They are equivalent, so you can write either one. But if it's multiple choice, make sure that you recognize this as the answer as well, because those are the same thing. So 2 raised to the 4/3 plus 1, or 2 cube root of 2 plus 1. That would be the x-intercept. And now, increasing, it's definitely increasing. Okay, let's do one more, and then we'll finish tonight's lesson, and you can take a look at those tests. So, number 7. Number 7, I mean, I would do the same thing I did on number 6. We want to make a table so that we can apply these transformations. But we need a table of the parent function. So the parent function for that would be the natural log of x. So y equals natural log of x. We need to have a table for that. Once we have a table for the parent of y equals natural log of x, then we can apply those transformations. But the problem is, like, I guess to me it's hard to just make a table for the logs. So I always make a table for the inverse first. Like I did over here for log base 2, I made a table of the inverse first. So that's what I'm going to do here first. I'm going to make a table of the inverse. So first of all, inverse. The inverse of y, natural log of x, is going to be x equals natural log of y, because I'm switching the x and the y. So the base here would be e to the x power equals y. Okay, so that's the inverse. The inverse is the y equals e to the x. So let's make a table for the inverse. Inverse table. Y equals e to the x. So I'm trying to squeeze it all in here. For this one, we're only going to put 2 points, like the 0 and the 1, because you're supposed to just memorize that e is about 2.7. So if x is 0, e to the 0 is 1. If x is 1, e to the 1 is 2.7-ish. So that's the table for the inverse, which is e to the x. Now I want to have a table of the log function. So to make the table of the log, we can just flip these around. So instead of 0, 1, 1, 0. Instead of 1, comma 2.7, 2.7, comma 1. So now that's the table that I'm going to work on from now. So this is the table of the log, and now I can apply whatever transformation I need to. So now let's apply the transformations. For the x transformations, there's just going to be to the left one, because although it says x plus 1, that is to the left one. So I'm going to do x minus 1. For the y transformations, there will be a negative, multiply your y values by negative 1 plus 2. Negative y plus 2. So now that's what I'm about to do to the parent table of that natural log. So 1 minus 1, 0. 2.7 minus 1, 1.7. Negative y plus 2, 2. Negative 1 plus 1, 1. And now I'm just going to graph those 2 points. Don't forget to graph the asymptote first, so x equals negative 1. Over here, it's a big mess. So now graph 0, comma 2. 1.7, comma 1. So this thing, instead of going up and to the right, now it's going this way. Okay, I missed the top, but that's okay. It's been the negative makes the graph reflect over the x-axis, so now it's going that way. It's supposed to go through there. So that's enough. That's good enough. And now you gotta just answer the questions, such as the domain. That's just gonna be from negative 1 to infinity. The range is always all real numbers. The x-intercept, I don't know. We're gonna have to find the x-intercept by looking at your function, plug in 0 for y, and solve for x the way I did on number 6. So I guess we could just do it down here. We would have to put 0 equals negative natural log of x plus 1 plus 2. Solve for x, so do a minus 2 and get rid of the negative. So it'll just be a positive 2 equals natural log of x plus 1. Then to solve for x here, we would have to change this log into an exponential. The base is e. So it would be e squared equals x plus 1. And now I can just do a minus 1. So the x-intercept looks to be e squared minus 1, comma 0. And you would just leave it like that in terms of e squared. The y-intercept, I think we already have it on the y-axis here. The y-intercept was 0, comma 2. 0, comma 2. If you didn't have it, then you would have to go to your equation and plug in 0 for x so that you can get the y-intercept. For this one, it was 0, comma 2. Last thing, you need to look at increasing or decreasing. So as x gets larger and larger, the y values are getting more and more negative. They're decreasing. They're getting smaller and smaller towards the negative. So that's called decreasing. And now, that's how you're supposed to graph logs. So you need to practice. You have 2 homework assignments today. Please make sure you complete them by midnight to get full credit in not Delta Math, in your online math textbook thingy. So here they are. So for homework tonight, I need you to do Math Excel 7.7 and 7.8, which are just like graphing logs and doing some inverses. So that's what I need you to do today for homework.